Hello, friends. You're watching the New Generation Airships project. I'm Gennady, and we're here in Novinky. And for those who've forgotten, or those who have just joined us, let me remind you that the company AERONOVA and the New Generation Airships project have set themselves the goal of reviving the airship industry in Russia and beyond, and bringing these giants back to the skies. We're planning to install our tail assembly onto the envelope. We also plan to assemble and install the gondola on our airship, and we're already actively preparing to conduct the first flight tests of our very first airship, but NOVA-01. Right here, in this hangar, we are currently assembling and testing our airship. It is here, on this patch of land, that we will conduct our first flight tests. And I suggest that we go into the hangar right now and see how the work is going there. Let's go. Friends, Shamil is at the center of action. Shamil, share what you're working on and what you installed.
I've just installed the rear landing gear strut. We've secured it, and now we're working on the cable system, which includes carabiners, turnbuckles, cables, and thimbles.
And what function will those serve?
They'll hold the strut in a vertical position so it doesn't move during landing. We have a self-aligning wheel here, which could cause movement on its own.
So there will be cables here, they'll be tensioned, and where exactly will they be attached here?
They'll be attached to the stabilizers. The attachment points are, the first one is here, and the second one is farther away, near the end of the stabilizer. Here's a clear example of how they'll be set up. Let me show you right here. We have a carabiner, a turnbuckle, and a thimble installed here. There's also a compensator on the cable itself, which is this part. There's a loop here, and when the cable is tightened, the loop disappears. Everything here is insulated as well, so there are no sharp edges that could damage the envelope.
Yes, as you can see, we've also installed the tail assembly of our airship. We've tightened it up. Shamil handled all of that as well. It was also laced up. Is this the finished look? Or is there still something else to be attached here?
We're still missing the rudder. They're over there, and as soon as we have time, we'll install them.
So, this will be a turning mechanism, in fact, essentially a rudder that's mounted on the tail assembly. Got it. That's great.
We also installed the tail and nose reinforcements, ran the beams through, and secured them in the cone.
And here, on the tail, we'll be installing a steering device, which we'll carefully assemble and mount.
Yes, but here we're only missing the steering device and the cover that encloses all the metal structures.
So, friends, right now we have a truly unique opportunity. We just lifted our airship so that we can start working on its underside. And now I've invited Alexander so he can talk a bit about the part of the work he did here. And Alexander kindly agreed. Yeah, hello, Alexander. Hello, Yevgeny. What have you been doing here? What have you been working on? Anything interesting you can share?
So, we've lifted the airship's envelope so we can equip it. We've already fitted it with the filling valve, there it is, the black one up top.
So that's the one we used to fill the airship with helium.
Yes, that's absolutely right. Next, we have the flight termination device. It's this round thing here with a little square next to it. Inside that square, we have the electronics, which, when it receives a signal from the ground, will send a current to this wire. The wire will heat up and burn through the membrane. That's the membrane inside, and when it's burned through, the gas will escape, allowing our craft to safely descend in case of any unforeseen circumstances.
So basically, this is our emergency red button, which will let us land the airship in an emergency if something unexpected happens, like losing control or a failure of the onboard systems.
Next, we have a sleeve that essentially allows us to access the gas compartment so we can perform some operations on the components I mentioned earlier, or even just take a closer look inside to see what's happening with the envelope itself.
So, through this opening, this sleeve, we don't fill the gas. It's more of a technical opening that allows you to access the inside of the envelope.
Yes, exactly. Sometimes they even install a viewing window. We don't have one here, but it's possible to install it, a device like a viewing window that lets you see what's going on inside.
Transparent.
Yes.
Interesting solution. So, what's next?
Next, we have the pressure sensor and also a temperature sensor inside the envelope. We even upgraded it at the last minute. So, through this little tube we measure the pressure, and through this wire we can get the temperature and even the humidity.
Yeah, I remember during those envelope tests we didn't have that kind of measurement.
Right. We're always working on our solutions. We keep upgrading, making adjustments, so we're not standing still. We're always moving forward, step by step.
Awesome. So, right now this hose is connected to the pressure sensor, right?
Yes, yes, yes. The readings go straight to the monitor from it, so we can monitor everything in real time.
So later on, will it be sent to the onboard computer?
Exactly. We'll have a sensor on the gondola as well, and all the data will be transmitted down to the operator's control station below, so they'll also be able to see everything in real time. Also, the control board itself will be installed here, which will make decisions about when to turn the AVP on or off, or even send an alarm signal if needed.
By the way, right now, we actually have a great opportunity to observe the size of the ballonnet. At this point, we've currently lifted the airship, and we can clearly see that it's located in the lower part of our envelope, occupying approximately 30% of the total volume overall. And from here, you can clearly see its size and position. Alexander, could you please remind our viewers what the role of the ballonnet is?
Its main function is to compensate for changes in gas volume. When the gas volume decreases, the ballonnet gets bigger, and in the opposite situation, when the gas expands, the excess air is released.
So, Alexander, I remember we used to have pressure regulation valves for the ballonnet here, as well as air blowers. I see that they're not here now. Why was this decision made?
Yes, right now we're checking to see if there are any gas or air leaks. We're checking the envelope for air tightness, so we decided to remove both the valves and the AVP units, that is, the fans, from the ballonnet and replace them with plugs. So this is a temporary solution that will allow us to carry out various manipulations and measurements.
So basically, we're eliminating the possibility of pressure loss through these valves in the ballonnet itself, and right now we're checking the reliability of the gas envelope.
Yes, that's exactly right.
Alexander, we've already talked about this really wonderful net we have that keeps our airship from flying away before it's supposed to. It's held down by these sandbags. How much does one bag weigh?
Each bag weighs 10 kilograms. We have a total of 12 bags, so that's 120 kilograms altogether.
120 kilograms holding it down to the ground. I can see that in some places the bags are already lifting off the ground. So its lifting force is already pretty significant.
It's already at least 100 kilograms, and yes, it could easily lift a fully grown adult.
But we have to keep in mind that this envelope doesn't have the gondola, equipment, or engines attached just yet. so there's still more work that needs to be done before it's complete. What's the current pressure inside the envelope?
Right now, it's about 150 pascals inside. The operating pressure will be higher, so we'll add a few more gas cylinders and then we'll be ready to fly. Once our specialists equip the remaining parts of the gondola and the engines, the airship will be able not just to hover in place like a balloon, as it does now, but to actually fly right, left, up, and down.
To move in a controlled way.
Exactly.
So, the next stage of our assembly is installing the gondolas, right?
Yes, and the propellers.
So right now we're in the active phase of assembling the gondola. I don't know if we'll manage to install it onto the envelope today. Fedor, what are our plans for today? Well, it's unlikely we'll install it on the envelope today. That's why we set it up under the envelope. Test fit?
Yes. This is so we can get a general idea of where the VGS system controllers are located, where the sensors are positioned within the facility, and, additionally, to carefully ascertain the necessary length for the power and signal cables.
Some more of our team arrived today. Do they have a specific task, or are they just here to see how things are going?
They broke the battery, the onboard computer, and a bunch of other interesting stuff. They also came themselves to take a look and plan the work for Monday.
Dennis, what device is this? What role will it play on our airship?
The contactor is the protection of the entire, or rather, the shutdown of the entire onboard network. We will turn it on and off.
It's just a main switch that supplies power.
Just in case. Of course, yes, if this battery here were to short out on a wire somewhere, the wire would heat up and, well, you'd end up with a little hole right here.
Helps us avoid.
Well, the contactor. Yes, it's rated for 200 amps, but in reality, it can handle about 500 amps, while the battery can deliver thousands for a short time. So, if you short it out, this cable here would just turn to dust, basically become a heater.
Which could heat things up.
It would melt a hole through that's it. That's why our contactor is the main protection.
That's the fuse.
Yes, fuse. So, from the battery, we have the thickest signal cable running out. So, if something happens with any of the devices, we use this contactor to disconnect the onboard network, completely cutting off the power. We can also turn it on or off remotely whenever we need to. The contactor is powered by 24 volts through the computer, so we can use the computer to either cut power to the airship or connect it if needed. And just in case, for emergencies, that's what it's for, to make sure nothing happens.
My goal is to carefully account for the total weight of all the equipment that will be lifted by our airship. The gondola is also included in that list of equipment. That's why it will need to be weighed. When the specialists are done working on it, we'll have to figure out a way to get it onto the scales. We'll think about how to do that and weigh it completely. Please show it.
It's beautiful. Our workday is coming to an end today. Today, we carefully installed the tail assembly, which is a crucial part of our airship, and we also attached the rudders that we'll be using to steer and control its direction. And today, we still need to install the servos that will actually move the rudders on the tail assembly. We're also starting to assemble the gondola. We've installed the onboard computer and the batteries. Now we still need to set up all the electrical wiring and run the cables. And overall, starting next week, we'll be getting ready in earnest to finally conduct the very first flight tests of the NOVA-01 airship. So stay tuned, because our first flight is coming up soon. Let's go.